All right, so next, I just want to start going into some of the modeling fundamentals that are sort of underlying NetLogo. And so these are kind of inherited from agent-based modeling, but what are the specific things to NetLogo? And I'm trying to draw connections between some of the things that we've already learned about that are sort of generic to simulation in terms of the discrete event system simulation. So um, for example, entities. So by now we should all be familiar with entities in the terms of discrete event system simulation. There are entities in agent-based modeling and entities in NetLogo. So in agent-based modeling, they're generally called agents. Those are the things that are moving around. So if, you can kind of use those terms interchangeably when you're talking about agent-based modeling. Specifically in NetLogo, the agents are called turtles for historical reasons. So in the kind of default way that they're depicted are these little triangles that are kind of in the NetLogo logo. But those things can be changed. But the turtles can have different breeds, and the different breeds of turtles allows you to have different types of agents. So we talk about or types of entities. So we talk about, I could ask you, well, how many different types of entities are there? And then you could say, well, then you can then take those and subdivide them by their attributes. But sort of at a fundamental level, what are the different types? Well, in NetLogo, the different types are the breeds of turtles. Now, there are other types of agents other than turtles in a NetLogo that don't move around. So turtles are the agents that move around. So they're entities that are moving, but there are other types of entities known as patches, and they are kind of immobile cubes of the environment if you slice the environment up, sort of vertically and horizontally into little pieces. And so I still am calling these entities in terms of NetLogo, although in our discrete event system simulation framework, a lot of times the patches might be viewed kind of like resources or something like that. But fundamentally, they are the things that that are changing and that are sort of the inputs into the logic. And so I still kind of view them as entities inside NetLogo. But the terminology here doesn't matter too much. But you just have to know that turtles are the agents that move, and patches are the agents that they move on. And then there's a third type of entity that is not as used as much as the other two, and there's links. And so there's actually kind of a social networky simulation depicted here, and each one of the dots is a turtle that happens to be sitting on top of a patch, and turtles have relationships with each other, and those relationships can be formalized through another agent called a link. And those links can move around as the agents that they're tied to move around. So, and the links then can have their own attributes, just as the patches can have their own attributes, and the turtles and all the different breeds of turtles can have their own attributes. And so that's kind of why we still view the links as entities as opposed to just like some, I don't know, simple relationship or something. They really have agency in this modeling framework. So what do patches look like? Well, this is a case where we've taken the world, the NetLogo world, and then we've coarsened it so you can go into the settings and you can say, I only want my world to be so large. So I want my patches to take up this much space, and I only want so many patches to exist in the world. And then you can end up coloring the patches randomly, because color is an attribute that patches have. And then you end up getting this kind of funny checkerboard looking thing, and that's what's going on inside the simulation. Now, agents can move to different regions inside a single patch. So agents can move continuously, but there's just this framework where sometimes it's more efficient or it's easier to not refer to where the agent is in absolute or in the space, like with fine grained coordinates, but instead ask the agent which patch is it sitting on. And so there's a number of different types of models where it will make sense that to kind of cut up the world into pieces and then think about what are the attributes of that piece of the world. So the attributes that you naturally have is that every patch has an X and Y coordinate, which is the center of the patch. It has a color, P color, which is its color. and have a label. None of these are labeled right now, that if you set that attribute, it puts whatever that text label right in the middle of it, and then that label itself can have a color. These are things that you can set during the runtime of the simulation, and you can query. So you can ask, what patches are green right now? What patches have a label that's equal to this? What patches have a label color that's equal to this? So you can access all of those, both read and write. Well, so I guess the one difference is the X core and the Y core, those are only readable. So you can't change the X coordinate and the Y coordinate of a patch because, again, a patch is stationary. It doesn't move. But we still view those as attributes. They're just fixed attributes for the life of the patch. All right, and you can add your own. So I can define that, I mentioned earlier that ants can be simulated as laying pheromone in the world. Well, the way you typically do that is when an ant moves across a patch, you can ask that patch to increase some chemical attribute by the amount that models how much chemical the ant has laid on the ground. And then when the ant's not around, you can ask all the patches that haven't been reinforced by another ant to decrease their amount of that chemical over time, and that sort of represents it evaporating off. And so I could add like a chemical amount here, or a pheromone attribute. I could add all sorts of other attributes. Turtles. So this is sort of the traditional shape, this funny little triangular kind of GPS looking shape. Turtles, these are the things that move. So they're shown one per patch here, but you can have multiple in a patch, and they don't have to be centered on the patch as well. So turtles come with a bunch of attributes. Who, so that's a unique ID to the turtle. So there are unique IDs of the patches, and that's effectively their X and Y coordinate. This is patch 0, 0. This is patch -1, 0. This is patch 1, 0. So patches have are uniquely identified by their coordinates. Turtles, because they're not stationary, need their own special unique identifier, which is basically the order in which they were created. So you can ask a turtle who it is. You can't write to this attribute, but you can read it, and it will give you an ID for that turtle. Turtles also have an attribute which tells you what breed they are, what color they are. Notice there's multiple colors here. What heading, so effectively what direction that they're pointing right now. Whether they're hidden or not. So you can hide a turtle and it will kind of disappear, but it still stays alive. And so that can be useful in some of your models if you want a turtle to kind of go away for a little while, but don't want to recreate it later. Turtles can be labeled, and those labels can have colors. Turtles have a position, X core and Y core, and that you can query. And then you can also move a turtle, so you can effectively set those as well. So because turtles move, then those are important. They have sizes and shapes, so you can change the shape if you don't like it. You can change the shape during runtime even. That way you can indicate that this turtle shifted from one thing to another. Notice that the coordinates X core and Y core are different than the patch coordinates PX core and PY core. They do that so that there are shortcut ways for you to refer to patch attributes that are associated with the patch that a turtle is currently on, without having to go through a sort of a long string of code. And so you can actually sort of ask a turtle about certain patch attributes, and because every turtle has to be on a patch, and every patch has to have these attributes, and all these attributes starts with a P, then there are ways to referring to these patch attributes directly, almost as if they were turtle attributes. But once the turtle moves, it moves from this patch to this patch. Then, if you were to query the patch color, then it would change as if it changed on the turtle. So turtles kind of get access to their patch attributes just for convenience inside the modeling framework. Now I can add other attributes to the turtle. I can say how old is the turtle. I can say I can keep track of if the turtle has parents or if the turtle has offspring. I can also do those with links. I can do all sorts of things. So anything that I would be just like in a discrete event system simulation, I can add attributes to those turtles. Okay, so those are, and I mentioned there's links too, but I'm not going to go into great detail. So those are kind of the main modeling fundamentals in NetLogo, the idea of the patch and the idea of the turtle. Now, in this next section that we'll go into here, I want to start looking at the code, and then from that code, then we'll move into some examples, kind of demonstrating how all this works. So that's kind of what's up next. But I'm going to pause now, sort of as a nice place to stop, sort of now that we've gone over turtles and patches.